On the front of your packet, it should say one-step equations, okay? All right, so no solution. What's our first step whenever we are going to solve for x? Distribute. So negative 4 times 2x is? Negative 8x. Negative 4 times 1 is? Equals negative 8x plus 2. I'm going to add my 8x plus 8x. And then I get 0x, which equals 0. Yep. And then we have negative 4 equals 2. Is that a true statement? So because it is not a true statement, this when we say this means no solution, which you can also write like this. Okay, that means there's no possible number that is going to work for x to satisfy the equation, so both sides are equal to each other. Okay, no number works. All right, so if you end up getting something where your x's all cancel out and you don't get 0 equals 0, then you are left with no solution. On the other hand, let's do this side. So negative 5 minus 9x equals 3
minus 9x.
Combine my 3 and negative 8, and what do I get?
Negative 5.
Negative 5 minus 9x. Now we can see here that these two match, right? If I were to add the 5 to one side, add the 9 to one side, I would get 0 equals 0. But you can stop when they match like this, because this means all real numbers, or you can write it like so. So that means no matter what number you put in for the x, the answers will equal each other. So if it's 100, if it's 2,000, if it's negative 50, if it's negative 10 million, it's all going to equal itself, okay? It satisfies the equation. Yes. We want to do it either like this or like this, because we start to use the infinity for inequalities, so we don't want to use that here. We want to use one of these two, okay? All right, let's do this next one. So I'm going to go 3 times 2x, and I get 3 times 2 plus 6 minus 3x equals 6 plus 3x. All right, so now I get 3x plus 6 equals 6 plus 3x. Is that the same thing? Yeah. And you guys remember our properties from earlier? The commutative property says that order doesn't matter. So there's that commutative property in action. So that means it's going to be all real numbers.
Wait, how do you write that thing?
You do line, and then a big R.
Okay.
You would do that, or you could just write all real numbers. Either one. Okay, let's do 2. 6 times 2x is?
12x.
6 times negative 6 is?
Negative 36.
Equals negative 7 times negative 2?
14.
Negative 7 times 4? Negative 28. Okay, let's get our x's together. So I get 2x minus 28 equals negative 36. I'm going to add my 28. Add my 28. Negative 36 plus 28 is? Negative 8 equals 2x. X equals negative 4. All right, can I get someone to do, I'm going to hand you my iPad. You're going to do number 3 and explain it as you go. Who would like to do that? Okay, Grant, you'll do this one, and then Molly, you'll do the next one, okay? So explain it out loud to your classmates. Everyone follow along. After each step, we'll check it together, okay?
So first we have to distribute 40x. 8 times negative 3 is negative 24 equals 6 times negative 3x is negative 18x. 6 times negative 4 is negative 24. And now we have to add. So I want my terms on this side. (24 plus 24)
Does that all look good, guys? Yeah? Okay.
equals 0. And I can't do that, so it's a no solution, right?
Nope.
Infinite solution.
Nope.
It equals 0.
X equals 0. Okay? Here in this scenario, it is, a lot of people do think it would be just no solution, but what it actually is you can have 0 as your answer. So when you plug in 0 to the equation, you're still going to get both sides matching. Okay? 0 is different from no solution. Does that make sense? Okay. Molly. Explain as you go.
Alright, so first just keep these terms on this side the same. Then you need to distribute, so 7x plus 14 minus 4x plus 28. And then you need to combine like terms.
The left side stays the same.
Yeah, and then it would be 3x plus 42. And then I want my terms on this side, so I'll subtract 3x. And then add 13. And then it would just be 0. So it would be no solution.
It'd be no solution because you would get 0 equals, and you would have, what, 55 right here? So does 0 equal 55? No, so that is no solution. If you get 0 as an answer in this, they're going to be different. Okay?